Let's take a look at this warm-up. It says that Jada has $20 to spend on games and rides at a carnival. Games cost $1 each and rides are $2 each. So, got some important information there. So, number one, it's asking us, which equation represents the relationship between the number of games x, so number of games is x, and the number of rides, y, that Jada could spend if she spends all her money. So all of her money, well, we know that she's got $20 to spend. So this 20 in each of these equations, that's representing that total amount of money that she's spending. And then we also had some pieces of information up here that games are $1 each and that rides were $2 each. So these are going to be connected here. Games are $1 each, number of games is x. Rides are $2 each. The number of rides that Jada goes on is y. So like if I play 10 games and they're $1 each, I'm going to spend $10 on that. If I go on 6 rides and those are $2 each, I'm going to spend $12 on those rides. Okay? And to figure out the total, I'm just going to add the amount that I'm spending on games and rides together, and that's got to equal 20. So if we look at these three equations, the coefficients on like the x and the y here in A are both 1. So like 1x plus 1y. B, it's like 2x plus 1y equals 20. And C is 1x plus 2y equals 20. Well, the only one that works if games are $1 each and rides are $2 each is C. That's going to be my equation for this problem. So like in the first one, like in number 2, it's asking, explain what the other two equations could mean in this situation. So in this first equation, x plus y equals 20. All that's saying is that games are $1 each and rides are $1 each. B was a wrong equation, so let's write down and see what this one is saying. What is this equation telling us? This equation is saying that games are $2 each, since the 2 is with the x, and rides are $1 each. So that's kind of the opposite of what Jada's situation actually was. So with that kind of same idea, with that carnival, let's go into the example 1. So below is an equation, so I'm giving you this equation right here. X plus 4y equals 28. This equation represents the relationship between the number of games x, so as you see it's very similar to that warm-up, number of games x, and number of rides y. And the dollar amount a student is spending on games and rides at a different amusement park. Let's answer these questions. So we've got this equation, okay? So based off of what we did in the warm-up, we know that games are $1 each, because that's the one with the x right here. And then rides are $4 each. And we know we're spending also a total of $28. That's how much money we took to the carnival with us. That's how much money we have to spend on games and rides. So, number 1 is asking, what's the number of rides the student could get on if they don't play any games? If they don't play any games. That's an important thing there, because that's telling us that games, we did not play any of them. And games was x. So think about, what value can I plug in for x then if I did not play any games? I'm going to plug in 0. So I'm going to take my equation and I'm going to plug in 0 for x, and everything else can stay the same. And then I just need to solve this. So I got 0 plus 4y, that's just going to become 4y. 4y equals 28. divide by 4, y equals 7. So that means 7 rides. If I don't play any games, I can ride 7 rides. So I'm going to mark that point on the coordinate grid down here, 7 rides, 0 games, 7 rides. Right there, that's my y-intercept. That's where it crosses the y-axis. The next one says, what's the number of games the student could play if they don't get on any rides? So on this one, we're not getting on any rides. We're just going to the carnival to play games. So if we're not going on any rides, I can plug in 0 for y. So I've got x plus 4, and instead of y, I'm going to substitute in 0, equals 28. Well, 4 times 0 is just 0, so x equals 28. So we can play 28 games, which makes sense. If games are just $1 each and I've got $28, if I've got $28, I can play 28 games. So I'm going to plot that over here on the x-axis because the coordinates there are 28, 0. That's my x-intercept. I'm going to connect these. I'm going to use my nice tool, straight line, to connect those two. So we've got that line, which is the graph of the situation. So what's the slope? Well, if you remember, slope is rise over run. So you're going down 7, right 28. So negative 7 over 28, but you notice that fraction can simplify because we can divide a 7 out of each of those. So our slope is negative 1/4. Okay, so m equals negative 1/4. That's my slope. The next question is, where does the graph intersect the vertical axis? Vertical axis is just a fancy way. We'll erase that. That would have been wrong. Vertical axis is just another way of saying your y-axis because it's the axis that goes up and down. Well, it crosses the vertical axis at the point 0, 7. We already got that on the graph. So I can use my slope and my y-intercept now. I could write the equation of this line in slope-intercept form. Y equals negative 1/4 x plus 7. That's another way of representing this. So using that slope-intercept form, complete the sentences. If they don't play any games, they can get on 7 rides. We see that from the y-intercept value. And then for every additional game that I play, notice that the number of rides is decreasing decreases by 1/4. That's what my slope is saying. Every time I play a game, I can go on 1/4 fewer rides. So I know that fraction is a little kind of maybe tricky to kind of wrap that brain around. So one way to kind of see it is if I zoom in on this graph, if I ride one ride, or sorry. If I play one game, the number of rides has decreased by 1/4. So if I play a total of 4 games, the number of rides decreases by 1. There, so that's what that slope is saying. Oops, did not mean to erase that line, just erase that point. So that's what that slope is referring to. So for every additional game the student plays, so as x increases by 1, the number of rides decreases by 1/4. So lastly, we want to rearrange the equation to solve for y. So let me copy down this again. So if I want to solve this, if I want to rearrange to solve for y, I got to move the x over. So there's technically like a 1 in front of this x. So I'm going to subtract 1x from both sides. It's just we don't need to have that 1 there. We could just leave it as just x, like 28 minus x. And then to finish this out, to get y by itself, I'm going to divide everything by 4. So we got y equals 7 minus, and again, don't forget about that 1 that's in front of the x here. So minus 1/4 x, which is exactly what we got up in 5 when we wrote that equation of the line and slope intercept form in green there. It's the same exact equation saying that you're starting at 7 rides. If you don't play any games, you're starting at 7 rides, and that's decreasing by 1/4 for every game that you play. Okay? So that's the example 1. And then last little one here is example 2. The graph represents that equation, which describes the relationship between the gallons of water in a tank and the time in minutes. So what do the two variables represent? Well, our input here, our t value, is our time in minutes. We see that being represented by the x-axis. And then A, that's the amount of water in the tank. Okay? That's the amount of water in the tank. So where do I see that in that equation? We see that 450. Where do we see that on the graph? Well, I see that right here for the y-intercept. That's our starting place. We're starting with 450 gallons in the tank. So what does that number mean in this situation? 450 is saying this is the starting, or let me rewrite this. There were 450 gallons of water in the tank at the beginning. So that's what that 450 is talking about. Where do we see the negative 20 on the graph? Well, the negative 20 is a little bit more difficult to clearly see, but notice that negative 20, that is your slope. So it's saying when x goes up by 1, your y is decreasing by 20. So your slope is negative 20. You see we're going down 20, right 1, down 20, right 1, down 20, right 1. So your negative 20 here as your slope is saying the amount in the tank is decreasing by 20 gallons every minute. Because remember, your slope was negative 20 or negative 20 over 1. And if this is rise over run, the rise is talking about the amount. The run is talking about time, or how many minutes. So the amount is going down by 20 gallons every minute. So make sure you understand how you can interpret that slope and that y-intercept. This is a very important question to make sure you know the kind of sentences and that sentence structure that we should write there. Okay, so that wraps up the last lesson here. Make sure to practice. If you have any questions, please let me know.